This is your host Swapnil Bhartia and welcome to TFR Newsroom. Kong recently announced ZeroLB, a modern decentralized load balancing pattern that aims at simplifying load balancing by removing every load balancer that is being deployed in front of individual services and applications. But what exactly is ZeroLB pattern? And why is Kong tackling load balancing at this time? Let's talk about that. And today we have with us once again Marco Palladino, CTO and co-founder of Kong. Marco, it's great to have you on the show.
Thanks for having me here.
Why suddenly you felt, not suddenly, but that load balancing need to address some of the challenges. So talk about what challenges that were there and that led to kind of creation of ZeroLB pattern.
Yeah, so ZeroLB really is something that we've seen our customers doing in production. It's not something that we planned ourselves. So we were observing how the customers are using our products, and one of the most common use cases was using the service mesh to get rid of centralized load balancers. Centralized load balancers, we deploy a load balancer in front of our services, and for each service, there is a load balancer. When we look at the pattern, it is quite of a monolithic and legacy pattern. We have a centralized load balancer in front of a decentralized architecture, which doesn't sound right, and in production also doesn't look right. There is a few problems that centralized load balancers introduce. And so that's why we wanted to codify this new way of doing things with the terminology ZeroLB.
Can you go a bit deeper into explaining this pattern, ZeroLB pattern? You did allude to how you look at it, but if I want you to just go in a bit detail.
We look at the traditional centralized load balancer. And when we look at that, what we're seeing is a single point of failure, an extra hop in the network, something that for the most part, it is not very smart. Therefore, they cannot introduce enhanced service level security or observability because they have a very flat view of our services. And also, we typically look at something that's expensive and something that is not portable. Why do we have it? With a decentralized pattern like service mesh, we can deploy decentralized load balancers that are close to the services. They are portable because primarily they're built on top of open source implementations. So they can be carried across both our data centers as well as the cloud. And in the cloud, they can work across every vendor. They are smart because they provide smart security and intelligence and observability to every service that we have. We can improve the performance by 2x by removing extra hops in the network. So the service request goes directly from one service to another, and they are built in with our service infrastructure, which means that we do not have to use all these cloud load balancers or enterprise load balancers to perform these functions. I was speaking with one of our enterprise customers. They were able to remove 16,000 elastic load balancers from one of their cloud vendors by leveraging ZeroLB. This gives them more performance at a lesser cost. It's a no-brainer.
Can you also talk about what kind of architectural changes they have to make? You mentioned they had to remove 16,000 or more, and that's and also how does it integrate with service mesh solutions, whether it's NY or whatever customers are using, and of course Kong service mesh there. So talk about that as well.
ZeroLB is what I call cloud native load balancing. Our load balancing, the one that is decentralized, the one that we're used to deploy, it is not cloud native. It really belongs to a different era of software. So with cloud native load balancing, we can deploy these load balancing features and capabilities on the same sidecar proxies, the data plane proxies that we run in a service mesh to provide all the other functionality for our underlying API infrastructure. These load balancers are decentralized. In the case of the products that Kong is working on, Kuma, which is a CNCF project, we are one of the maintainers, as well as Kong Mesh, the enterprise service mesh. It's built on top of Envoy proxy, and we provide an automated way to inject these sidecars across both Kubernetes, containers, and virtual machines. And out of the box, all of the services that have this sidecar next to them, they get these enhanced load balancing features that we call ZeroLB for zero trust security, for observability, for routing across different algorithms, like round robin, least connect, maglev, and so on and so forth. And all of this is dynamically propagated. Now, because the requests are going straight from the sidecar to another sidecar, there is no extra hop in the network. This means that we can intelligently route our software, but also in a more performant way. In microservices, speed is not a nice to have, it's a must have. If microservices are slow, our applications are down. In a monolith, if the app was down, the monolith was down, the application was down. But with microservices, if they're slow, they are down. So being slow is the new down. Being slow, it's like being down. So we have to improve that performance, and ZeroLB allows us to do just that.
What are the other benefits that ZeroLB provide in addition to these two or three things that you mentioned?
Well, it also allows us to build applications in a much more predictable way. Traditional load balancers, especially the ones that are either enterprise or in the cloud, they're very hard to provision when we develop our software. Therefore, the load balancing behavior, it's always an unknown until we finally deploy it in our production environment. Whereas with ZeroLB, it's lightweight. It runs locally as we develop the software. We can manage it, instruct it, deploy it, run it as we build our software. And we can do that in a very consistent way across every infrastructure. So today, if I'm deploying, let's say on Amazon, and I'm using the elastic load balancer that Amazon provides, but then I want to also deploy software on Azure, and every major enterprise in the world is multi-cloud, we're going to be having different load balancing behavior across the board, because the load balancer that Amazon provides and the ones that Azure provides, or the ones that we have deployed in our data center, they are not portable across different environments. The load balancing behavior, which is on every single execution path of every single API or service traffic request, it is not predictable, it is not portable, which is madness when we think about where the industry is going. And so with ZeroLB, we can have predictable behavior because the underlying service mesh does support every cloud. It supports VMs, it supports containers, it supports Kubernetes, supports pretty much everything, and everything works the same way across the board. And as we're building our software, we can also provision it locally. So there is no surprises when we run our application in production, which in turn will accelerate time to market and delivery of our applications.
Are there any caveats also that companies who do want to leverage ZeroLB should be worried about? Though, as you mentioned earlier, when you embrace the architecture, you're moving from monolith to basically more cloud native. But if there are anything that they should be aware of?
Well, they should be aware of the existence of a better way of doing load balancing, which is why ZeroLB is something that we are promoting. And again, this is something we've been seeing from the actual users and customers. It's not something that we initially even thought of, and then it makes sense reconnecting the dots. The challenges are, obviously to enable ZeroLB via a service mesh. And service mesh, by any means, it's not the only way that ZeroLB can be implemented. Smart clients could be another way. But with a service mesh, it's important that we choose a technology that can allow us to implement that load balancing across both the greenfield applications, which are going to be running on containers and Kubernetes and the cloud, and the brownfield ones, because we want to at one point migrate some of them to the cloud. And the load balancing, the ZeroLB pattern, which is a smarter way to also implement blue-green deployments and canary releases, allows us to do just that. It allows us to more easily transition, lift and shift all their workloads to the cloud and to Kubernetes. Choosing a technology that can allow us to support these in a uniform way, it's probably one of the biggest choices an architect can make. And obviously, being the CTO of Kong, I deeply empathize with this problem, and that's why we're trying to provide a product that allows them to run ZeroLB pretty much everywhere. And that's why Kuma was the first service mesh, which is now a CNCF project, that came out with native first-class VM support in addition to containers. Obviously, there is first-class support for containers as well, and it can run pretty much everywhere. There is no service mesh that matches that level of support for both containers, Kubernetes, and virtual machines, and hybrid.
You folks have also released, you also mentioned that earlier, Kong Mesh 1.4. And it has, as you said, ZeroLB support built into that. Can you talk a bit more about the integration there?
Yeah, so we have introduced many more load balancing capabilities. There is 5 different load balancing algorithms that the users can decide to enable, and they can choose different algorithms based on different traffic paths. So we may say, within this region or this cloud, I want to use round robin, but these other traffic requests going to a database should use a different algorithm. And then on top of that, we have introduced a service map topology view, which is a GUI that allows the user to visualize all the traffic going from one service to another, including the rate of requests, the error rate, and the latency of these requests, in such a way that however we decide to connect our services together, we always have a bird's eye view to make sure that the status is always up and running. There is 70 plus charts and observability charts that Kong Mesh and Kuma already provide out of the box. So this is going to be in addition to all the observability infrastructure that already is there when using the service mesh, as well as we have introduced capabilities of being able to apply these load balancing routes across different subset of the traffic paths. So it's not just traffic between one service and another service, but is a subset of requests generated by that service should have this or that different load balancing algorithm. So it's very fine-grained in the way we can control load balancing across the board. Centralized load balancers, they do not allow a fraction of this, while costing us more because we have to pay for an extra component, having more bandwidth, and having an extra hop in the network, making everything slower. So it's really a no-brainer.
Awesome. Marco, thank you so much for taking time again out from your schedule and talk about not only ZeroLB, but also how you are kind of helping customers reduce the complexity that is already there in the Cloud Anywhere. Thanks for your time today. And as usual, I would love to have you back on the show. Thank you.
Thank you for the opportunity.